Okay, complex fractions. All right, so we're definitely going to have to do some algebra with number 11 and number 12, because if we look at what we would be plugging in, both of our denominators are going to become 0. So I went ahead and made my 3 into a 3 over 1, because if we're going to have fractions, we might as well have all fractions. And now we need to create a common denominator in our numerator. Again, I'm going to be picky about requiring you to keep doing the limit notation, and you're going to be picky about remembering it. I have 3 over x minus 3. And so to create a common denominator, I'm in a fancy form of 1, multiply that 3 by x over x. So my numerator of my fraction is going to be 3 minus 3x all over x. And the denominator of my fraction is x minus 1. So I'm going to go ahead and put that over 1. Might as well do all fractions. If you're going to have one fraction, make them all. Okay, so from here, you have options. Some of you like flip the second and multiply. If you're doing that, the bottom is your second. That's what you're going to flip. Some of you like to group. The stuff on the outside goes on top. The stuff on the inside goes on the bottom. Whichever you like, go ahead and pause the video and make that fraction situation happen, and I'll meet up with you at that next step, after you've flipped or after you've grouped. So after you've flipped or grouped, your numerator is 1 times 3 minus 3x. And your denominator is x times x minus 1. We can do a little more factoring here. In the numerator, my two terms have a 3 in common. So I can factor out a 3. Okay, here's a situation where it's really tempting to cheat, but don't do it. Don't cheat here. Right now, we are not in a position to cancel our 1 minus x and our x minus 1, because they're not exactly the same. In order to cancel, canceling is fancy division. So when we cancel, we have to have exactly the same term on top as we do on the bottom. That's not the case here yet. To create that, what we can do is factor out a negative, either on top or bottom. I'm going to do it in the numerator. The reason I'm going to do that is because my 1 minus x and x minus 1 differ by just a negative. So if I take out a negative here with this 3, I need to switch the signs in the parentheses. And what that does is in my parentheses now I have negative 1 plus x, which is the same as x minus 1. So now those terms are definitely cancelable. So you want to look for that to happen, especially with complex fractions. That just needs to be kind of a tool in your toolbox, something that you know you can do if needed, if you see that your terms are off by just that negative. Now they have to be off by a negative with both. It has to work to switch both the signs, not just one. So now I'm taking the limit as x approaches 1 of negative 3 over x. And since I'm not going to get a 0 on my denominator now, I can plug in to evaluate the limit. This is the appropriate time to stop writing that limit notation. And so negative 3 divided by 1 is negative 3. Lovely. So that was a little trick back from Unit 1 is the last time we did that. Well, maybe on the semester exam. And maybe on the exit exam review, you might have seen that, or test, you might have seen that as well. That is an important thing to keep in mind. Okay, number 12, one more complex fraction, and then we're on to some of your infinity rules that are a little bit less intensive here. Okay, so for number 12, the limit as x approaches 0. Clearly we can't plug that in the way this looks right now. So we've got some work to do. I'm going to go ahead and put this x over 1, and I need a common denominator. Now it's very tempting to just want to do the same thing we did in number 11 and multiply our 1/2 there by x over x. But when you multiply by 1 over x, you're not going to make 2 plus x by x. So I'm going to multiply my first fraction, the 1 over 2 plus x, by 2. And I'm going to multiply my second fraction by 2 plus x over itself. And that's going to create the common denominator of 2 times 2 plus x in my numerator. Oops. In my denominator, or in the numerator of my numerator, I have a 2 minus 1 times 2 plus x. I'm going to leave that 1 there so that I remember to distribute the negative. And my denominator is still just x over 1. Not quite ready to flip the second and multiply or group. I'm just going to keep going to get as simple of a fraction on top as I can before I go any further. So I'm going to distribute that negative 2 minus 2 minus x. And my 2's are going to cancel there, so I'm just going to end up with a negative x on top. And now is a great time to either group or flip. So if you're going to flip, you're flipping the denominator. And if you're going to group, you're going to do negative x times 1 over 2 times 2 plus x over x. So go ahead and pause the video and meet me in the next step. All right, hopefully you have that next step written down, and if you do, you're probably already canceling and flying through the problem. Our numerator is going to be negative x times 1, just negative x, and our denominator is x times 2 plus x. So what we can cancel now are those x's, but be careful, you still need that negative on top. So I have negative 1 in my numerator and 2 times 2 plus x in the denominator. And now, since we're not going to get a 0 in the denominator, when we plug in, we can plug in to evaluate the limit. Lots of algebra, lots of precision work. None of the steps are difficult, but there are a lot of places that you can make mistakes. So double check your work, go slow, and the next video is going to be all about our asymptote rules and end behavior.